Many of us still remember exactly where we were on July 20th, 1969. We remember the static on the television, the bated breath in living rooms across America, and the collective leap of faith when Neil Armstrong's boots pressed into the lunar dust. In that singular moment, we didn't just win a race, we redefined what human beings were capable of. We did the impossible using guidance computers with less processing power than the key fobs sitting on your kitchen counter today. And yet, after just 6 landings, the Apollo program was cut short. We simply walked away for over 50 years. Why? A country possessed the absolute confidence to go to the moon and then chose to stop. How does a civilization just go backward? How do we lose that kind of momentum? If you look online today, you'll find endless rumors trying to explain why we never went back. People point to grainy photos of the moon's far side, claiming NASA discovered alien bases, strange lights, or classified UFO footage that the government locked away. It's easy to see why those stories spread. It is far more exciting to believe in a massive interstellar secret than to face the cold, disappointing reality. Because the official record isn't a sci-fi movie, it's much more ordinary and more heartbreaking. We didn't leave the moon because we encountered something terrifying in the dark. We left because Washington looked at the price tag, panicked, and refused to pay the bill. To understand how we went from winning the ultimate race to pulling the plug, we have to look back at the moment it all started. In May 1961, when President Kennedy promised the moon before the decade was out, he wasn't speaking as a dreamer. He was a leader in a panic. The Soviet Union had just put Yuri Gagarin into orbit, while America's own rockets were exploding on live television. We were losing the Cold War in front of the entire world. Kennedy needed a finish line the United States could actually win, and the moon became that finish line. Apollo was never a love letter to science. It was a weapon, the most beautiful and expensive weapon ever constructed, built to win a war fought entirely over global perception. And it worked. Armstrong's boots touched the lunar surface on July 20th, 1969, and the political objective was complete the moment that image transmitted back to Earth. The race was won. And the people controlling the budget in Washington looked at a program consuming 4.41% of the entire federal budget, nearly 5 cents of every tax dollar incinerated in rocket fuel, and started doing different math. By the time Apollo 17 lifted off from the Taurus-Littrow Valley in December 1972, Congress had already killed 3 more missions. Apollo 18, 19, and 20, some already assembled at Kennedy Space Center. Cancelled not because the engineering failed, but because the political purpose had expired. Gene Cernan stepped off the surface, climbed the ladder, sealed the hatch, and humanity's last words on the moon were, "We shall return." 52 years later, those words are still a promissory note we haven't fully cashed. But the damage wasn't only financial. The engineers at Marshall Space Flight Center discovered it when they tried to rebuild what had been lost, something called tacit knowledge. Tacit knowledge is everything a master craftsman knows that cannot be written in a manual. Think about the difference between reading a sourdough recipe and having a baker with 30 years of experience show you how the dough should feel at exactly the right moment. The recipe can be stored forever, That feeling cannot be transferred by any document, only by standing next to someone who has it until your own hands learn what theirs already know. The engineers who built the F1 engine, powering Saturn V's first stage with 1.5 million pounds of thrust per engine, solved thousands of near-fatal problems through years of hard-won intuition, combustion instability, turbo pump failures that sent shrapnel through the test stand. They fixed all of it, and almost none of that problem-solving logic made it into official documentation. To those engineers, it was just obvious. You didn't write down that water is wet. When Marshall later attempted to reverse engineer the F1 from surviving blueprints, they kept hitting walls. The documents described what the engine was. They couldn't capture why. The knowledge had walked out the door inside minds no longer available to answer questions. Boeing's Starliner in 2024 showed what that erosion looks like. Helium leaking from the propulsion system. Slowly, silently, like a birthday balloon forgotten in the kitchen corner. A little lower each morning until it's lying on the floor. The teams couldn't diagnose the root cause. Butch Wilmore and Sunita Williams spent 9 months at the ISS instead of 8 days. One broken Teflon seal. That is what tacit knowledge costs. But before we talk about where we're going, we need to sit for a moment with where we're actually trying to go. Because the moon is one of the most hostile environments in the known universe, and the fact that it hangs in our sky looking calm and familiar is one of the cruelest optical illusions in nature. Stand on the lunar surface, and the first thing that hits you is the silence. True acoustic silence, because there is no atmosphere to carry sound waves. Your suit systems hum inside your helmet, but outside is absolute muteness. The Apollo astronauts described it as disorienting, an absence so complete it felt less like peace and more like being erased from the world. Then there's the dust. Lunar regolith is nothing like beach sand. On Earth, millions of years of wind and water round rock particles until they're smooth. The moon has had neither. Every grain is a freshly fractured shard, shaped like broken glass at the micro scale. It worked through Apollo spacesuit outer layers within hours. It scratched helmet visors. It clogged the lunar roving vehicle's radiators and caused overheating. NASA's post-mission reports flagged the same anomaly across every single landing. Dust worse than designed for. The Artemis architecture includes glass-paved landing pads for exactly this reason, melted from regolith itself using a focused lens, because you can't bring pavement from Earth. Then there is the radiation. Because the moon has no atmosphere and no magnetic field, it has zero protection from space. The sun bombards the surface with deadly radiation, alongside cosmic rays traveling from deep space. It is a silent, invisible crossfire. Without thick shielding, an astronaut out in the open during a solar storm would absorb a lethal dose in just a few hours. That is why the lunar habitats we are building cannot just be tents or thin metal pods. They must be buried under 6 feet of heavy moon dirt just to keep the human inside alive. But that brutal environment is exactly why we are going back. Deep inside the craters at the lunar South Pole, there are places where the sun hasn't shone in billions of years. It is colder than Pluto, and because of that eternal darkness, ice from ancient comets has been frozen there, perfectly preserved like a time capsule. We are going after that ice. If you melt it, you get drinking water. If you zap that water with electricity, you split it into hydrogen and oxygen, which is the exact recipe for rocket fuel. By harvesting the moon's ice, we can manufacture our own fuel right there on the surface to launch our rockets back home. To run all of this, We need power. NASA is currently building a small nuclear reactor designed to fit inside the bed of a standard American pickup truck. It weighs less than 6 tons but generates enough continuous electricity to power a small office building. 1 unit will jumpstart the first outpost. 4 units can power a permanent research station. But the real reward of this 50-year wait is waiting for us in the dirt. Inside the vaults at Johnson Space Center, there are sealed containers of moon rocks collected in the 1970s that have never been opened. Back then, scientists looked at their primitive tools and made a remarkably honest decision. We aren't good enough yet. They locked the containers away, trusting that future generations would have better technology. They were right. Today, we are finally opening them and discovering helium-3, a rare isotope embedded in the moon's dust by billions of years of solar wind. It barely exists on Earth, but on the moon, it is everywhere. If we successfully harness it through fusion energy, the lunar dirt contains enough clean fuel to run human civilization for centuries. The moon isn't just a destination, it is a vault, and it took us 50 years to build the key. And yet, a part of us never truly left. Every single night for the last 55 years, scientists in New Mexico have fired a laser pulse at the moon. It travels 250,000 miles, strikes a small panel of mirrors left behind by the Apollo 11 crew, and bounces straight back home. That equipment has never been repaired. It has survived radiation, solar storms, and 300-degree temperature swings, and it still responds every single night. That isn't a metaphor. That's physics, but it feels like a message. When Orion, carrying Artemis II, Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, swings around the far side of the moon on its free return trajectory, the spacecraft will slip behind the lunar body and lose all contact with Earth. For 40 minutes, Mission Control will watch the telemetry screens go flat. No data, no voice, no confirmation that 4 human beings traveling at over 1 kilometer per second are still alive. Inside Orion, flying aboard the Space Launch System Block 1 generating 8.8 million pounds of thrust at liftoff, the most powerful rocket flown since Saturn V, the crew will be the most isolated human beings since Apollo 17. No news, no signal, just the hum of the life support system and 3,474 kilometers of ancient rock between them and every other living person. They trained for this for years. Because Artemis II is not the destination, it's the proof of concept for the crew that lands and the permanent presence that follows that. And they won't be alone in the ambition. SpaceX's Starship, already selected as the human landing system for Artemis, has completed multiple full-stack flight tests and caught its own booster with mechanical arms at the launch tower. Blue Origin's Blue Moon. Mark II is in development as a competing option. For the first time in spaceflight history, serious private capital has a financial stake in permanent human presence on another world. Political will evaporates when administrations change. Capital is harder to kill when there's a return on investment. China's CNSA is targeting a crewed lunar landing before 2030. The race is back. Not a sprint to plant a flag and leave, but a sustained competition over who defines the architecture of what comes next. The plaque on the Eagle descent stage, still sitting in the Sea of Tranquility since 1969, reads, "We came in peace for all mankind." Every word is still perfectly legible in the vacuum, unweathered, unchanged, waiting with the patience that only an airless world can sustain. "50 years was not an abandonment of that plaque. It was the cost of what it actually takes to honor it. The universe is cold and entirely indifferent to us, but we have each other, and we have the hunger. The embers Gene Cernan left behind were never cold. They were waiting for enough oxygen to catch. The footprints at the South Pole haven't been made yet, but they will be. And this time, we're not leaving. If you enjoyed this journey back to the moon and want to explore more of the incredible history and science of our universe, please take a moment to like this video and subscribe to the channel. Keep your senses open. Our journey continues. Out.